I just lost somebody. Brandon.
Is disappointed in the slowness of your computer.
Yeah. Here, why don't we take a quick 15-minute break? I'm going to set everything up. So we'll see you guys 7:35. So let's start playing Dispatcher. We did our weight and balance yesterday. Look how pretty it is. Got everything figured out. We're in CG. Got our route briefing guide here. Okay. One thing that we didn't do was check the NOTAMs for our departure airport, San Diego. So I just wanted to run through those really quick. Just give them a quick once over. Okay. So let's look at our NOTAMs here. San Diego, this ADAP, that's Aerodrome Airport, RVR all out of service. Okay. So when we see those ADs, those you need to like hyper focus on and make sure you read that because it's something that affects the entire airport. Okay. But we can see that this doesn't affect our ETD or ETA, so we're outside the valid time. Runway 27, the PAPI's out of service. Don't care because we're taking off. And then San Nav, the voice over transmission, I can't remember what. VO2 ground receiver checkpoint. Yeah, it's like voice over transmission ground receiver checkpoint. Nothing that affects us. Okay. When we're looking at our departure airport, if it doesn't say SID on it, we don't care. Okay. So instrument approach plate, arrival, SID. Okay, SID, RNAV, don't care. SID, Falcon 1, Border 7. Okay, we're using the Border 7 departure, so we need to take a quick read of this one, okay? Takeoff obstacle, runway 9, temporary crane, 1,666 feet from DER, 744 feet right of centerline. So it's just saying that there's a crane out there that pilots need to be aware about. Doesn't affect us. I guess ODPs also we kind of want to look at. Obstacle departure procedure. So it's a SID, but they're climbing over an obstacle, right? And it's just identifying the same exact tower. SID, Pogi 5, which is a RNAV, don't care about. Star, don't care about. Star, don't care about. SID. And it's the Lindsay 5 departure. We're using the Border 7, so we don't care. So we've gone through all of our San Diego NOTAMs. We've gone through all of our Salt Lake City NOTAMs. And we found that there's nothing that really affects us at all, right? Which is pretty nice. Let's see. What we don't have on here is our winds aloft. But we'll worry about that when we get to it. So that being said, and then here's our beautiful flight plan that we've come up with. So let's look at what we got here. The next thing that we need to do is we need to figure out a couple things for our flight. We need to figure out how high are we going to fly, like how high are we capable of climbing to, and we're also going to figure out we're going to, well, I don't know that I want to do that. Seems like it works better when we don't do that. So, talking to myself here, sorry. So let's take a quick look at some charts here. So in your flight plan folder, and I hope everybody's on and I'm not talking to myself. So well, I might need to change the batteries on my mouse really quick. The crap. All right. Hold on, I'm going to change the batteries on my mouse real quick. I keep losing connection. All righty. What are these? That's really weird. I don't even know where those came from. Hmm. All right, so you guys have this PDF for the flight plan packet. You guys, what I recommend you guys do before class, before we get into the classroom setting, is I want you guys to print these out. If you guys could print out the CRJ 700 performance, so this one, oops, this one right here, and this one right here, and this one right here. What I've done is, like, this is the front. This is the, if you're making a book here, this is the first packet. This is the second, and this will be the last one. Actually, no. This one, then this one. I wouldn't print them at home. If you go to like Kinko's or FedEx or something, just have them do like a spiral bound of it. Or if you guys want, I can have one made for each of you guys in a
Do
spiral.
that. I'll pay you.
Yeah. I was going to say, since I know what you guys kind of need, might be easier that way.
Yeah, I'll Venmo you the money. Just let me know.
Yeah. Why don't we do that? So I'll make them up and then I'll just have them in class the first day.
I can just bind my own. Which ones is it?
So do this one first, this PDF second, and then this one third. Oops, this one right here, third.
Okay, will do. Thanks.
Yeah. So it's only like $10, but yeah. The electronic copy works as well if you guys would rather just use the electronic copy. But I kind of like having it. Yeah. In paper in front of me.
By the way, are you going to be there all day on Monday, or what's your
Yeah.
plan?
Yep. I'll be there Sunday night.
Okay.
So I will be
I've got the
there.
test in the morning.
Starting Monday.
What was that?
What time are we starting Monday?
Well, just normal class time. If you guys want to meet up and, hang out or whatever, I'm all for it. But if not, then you know, I can just take that time to get some stuff prepared. I don't know. Either way, I'm game for anything. But, okay. So let's go into altitude selection really quick. Okay. So if we are looking at selecting an altitude, okay, there's only a certain altitude that we can reach depending on our weight and depending on the outside air temperature, okay? So the way we figure this out, if you guys can all see this page here, can everybody see it good enough? I kind of don't want to
Yes.
zoom in anymore. Okay, you'll notice here that there's some information that we kind of need to gather before we can even do our altitude selection. The main thing is, well, okay, the two things that we have to select our altitude are our takeoff weight, okay, our takeoff weight, and then our ISA deviation. So we're going to figure out how to do ISA deviation really quick. And it's really not that hard. But sorry, my 5-year-old daughter was sent on a mission to come and give me a purple nurple for some reason. So, um, anyways, okay. So METAR. We need to figure out, in order to find our ISA deviation, we need to figure out what our outside air temperature currently is at our departure airport. Then we need to figure out the altitude of our departure airport. Okay. So right now in San Diego, it's 24 degrees. So we take that 24 degrees, then we come over here to our Jeppesen chart. Okay. San Diego. Okay. This very first page will tell us our field elevation. Our airport elevation is 17 feet, so we can just call that sea level, right? Everybody good with that?
Where did you see the 17?
So right here,
Oh, okay.
right when you click into
I
the
had it
Jeppesen
scroll.
chart. Oh, you're good. So right as soon as you jump into the Jeppesen charts, it should be on that first page. If it's not, and it looks like this, your field elevation will be, you can use any one of these runway elevations, right? Also, it's like Laramie right there, airport elevation 7284. Okay. So it will always be on that first page that you open up. It just might be in a little bit different spot. If you look at this page, okay, this is Phoenix, airport elevation right there. All right. Okay. So San Diego is 17 feet above sea level. We'll call it sea level. And our current outside air temperature is 24 degrees, right? So the way we find ISA is we take our outside air temperature and then we take our elevation. Okay. And we're going to figure out what our ISA is for our field elevation. This one's really easy because we're at sea level. But let's say that we're using Laramie that's 7,400 feet above sea level. 7428, I think is what it said. So at 74, we'll round it up to 7,500 feet just to make life easier. Remember the standard lapse rate. So let's say this is 0 feet or mean sea level, okay? As we go up in elevation, so we have 1,000 feet, 2,000 feet, 3,000 feet, 4,000 feet, 5,000 feet, 6,000 feet, and here's our 7,000 feet. Okay, we'll go up just a little bit higher for our 7,500 feet. Okay, so our standard lapse rate, what's ISA at sea level?
15 degrees.
15 degrees Celsius, right? So as we go up in elevation, we lose 2 degrees per Celsius. That's our standard lapse rate, okay? 2 degrees Celsius per 1,000 feet, okay? So at 1,000 feet, what would our ISA be? What's our standard temperature?
13 degrees Celsius.
Okay, 13 degrees Celsius. Okay. At 2,000 feet, 11 degrees Celsius. 3,000 feet, 9 degrees Celsius. 4,000. You guys get the point here? 7 degrees Celsius. So this is these numbers here we call ISA, right? Everybody following? I need verbal confirmation.
Yep.
Okay. So let's see. So let's do the equation because we're going to have to do things like 35,000 feet, right? We're going to have to figure out ISA at really high elevations, and drawing it out like this is going to be, it's going to take forever, right? So let's do the equation. If we take our elevation, let's say our elevation, we round it up to 7,500 feet at Laramie. All we're going to do is we're going to move that decimal place point. Remember, there's like a decimal point right there, 2 zeros or whatever. We're just going to move that decimal point over 3 spots. So we have 7.5. Okay. 7.5, and then we're going to times that by a -2. No, not a -2. Scratch that. We're going to times that by 2. Okay. So 7.5 times 2 comes to 15 degrees, right? Everybody tracking? 17.5 times 2, 15 degrees.
Yep. Back in.
Okay. All right. Now, what we would do at that temperature, we know that standard at MSL is 15 degrees Celsius. Okay. All we need to do is subtract that number from our 15 degrees at sea level, and that tells us what ISA is at that elevation. Does that make sense? So if we continue this up 5 degree or 5,000 feet, 5, 6,000 feet, 3, 7,000 feet, 1 degree, 7,500 feet, because it's 500 would be 0 degrees. Does everybody see how that equation works?
Yes.
Very simple, right? So all you need to do, let's say that it's 35,000 feet. Move that decimal point over 3 spaces. So we have 35, multiply that by 2. That gives us 70. Then take 70, or take 15 and subtract 70 from it, and that gives us a negative 55 degrees. This number is ISA at 35,000 feet. Everybody understand?
Yes.
Yes.
No.
Okay, so we have found ISA, how to get ISA. Okay, now we need to figure out what our deviation from ISA is. Is it warmer or is it hotter, or I'm sorry, warmer or colder than ISA at our airport right now? Okay, so we take this 24 degrees. We know that our field elevation is 0 feet, so it's MSL. And we know that ISA is 15 degrees at mean sea level, right? So all we need to do is subtract 15 from that. That gives us 9 degrees Celsius, and it's a positive number, right?
Yes.
So what we would say is ISA plus 9 degrees Celsius. That is our ISA deviation. Super simple, right? Like, everybody understand how we did that?
Yes.
Okay. Let's do one. So we know that this is ISA plus 9. I'm just going to write this here so we don't have to go back and do anything. let's pretend that we have a winds aloft chart, and it says that the current outside air temperature at 36,000 feet is a negative 63 degrees Celsius. So let's figure out, this is flight level 360. Okay. So let's figure out what our ISA deviation would be if this is the case. 36, right? Because we moved that decimal point over 3 spaces. Multiply that by 2, that's 72 degrees. We take 15, subtract 72 degrees, and that gives us negative 68, no, 67. Negative 67 degrees, right? Check me, I'm not super good at math.
Yeah, that's right.
Okay, negative 67 degrees. This is our ISA. Okay, now to figure out our deviation from ISA, we take negative 67 and we,
It's 57.
57, my bad. Negative 57. And oh man, I don't know how to do this mathematically. I just know how to like spit it out. Okay.
it looks like you have to subtract the negative, which is really just adding. So it's negative 57 plus 63, which is 6.
So we take, that's what we need to do. We need to take our current outside air temperature. I just needed to figure out which one was on top, which one was on bottom. Okay. Let me erase all this. This is poopy. Okay. So we figured out ISA is a negative 57 degrees, right? At 36,000 feet. And our current OAT is negative 63 degrees Celsius. So what we need to do is we need to take our negative 63 degrees Celsius and subtract a negative 57 degrees Celsius from that. Okay. That gives us a negative 6 degrees. So OAT on top, ISA on bottom. This is our ISA deviation. We would say ISA minus 6. Comprende?
Hey, can I chime in for a second, Garrett?
Yeah.
So, one thing for me, just for you guys that are kind of looking and seeing this stuff for the first time, one thing for me that is kind of easier sometimes is when you get your ISA figure and you get your actual temperature. So you have your actual temperature, which in this case was negative 63. And then you have your ISA temperature, what the temperature is supposed to be in order to represent ISA, which is the negative 57. You have those two temperatures. Sometimes it's easy, at least for me, and like I said, I know everybody's styles are different, but just to kind of have another way in case it helps you. Sometimes I don't even really do the math on it. I just look at it and I say, okay, well, it's supposed to be negative 57, but it's really negative 63. Okay. So sometimes I just look at it from that perspective and I think, okay, well, in this case, is it warmer or is it colder than it's supposed to be? So it's supposed to be negative 57 and it's really negative 63, right? So in this case, and just remember when you're dealing with negative temperatures, you know, negative 63 is colder than negative 57, right? So in this case, it's colder than it's supposed to be, which means that it would be a negative, like ISA minus, right? And then just simply look at the difference between them. So, you know, what's the difference between 57 and 63? Well, it's just 6. I mean, a lot of this you can just visually look at and usually do in your head without necessarily actually having to do a math problem behind it, like a subtracting a negative number type thing. And so sometimes if you just look at it, which I appreciate the meme there. If you look at it, you can just look at it and say, hey, you know, it's 6 degrees colder than it's supposed to be. It's and so that therefore it is ISA minus 6. If it were 6 degrees warmer than it was supposed to be, it's ISA plus 6. So if that helps at all, then take it and run with it. If not, you know, do the math problem. But it's just an effort to maybe simplify it a little bit and just kind of have a different viewpoint. I just, on a lot of these things with the flight planning calculations and all these little different numbers you have to come up with, I just have these things in my head that I have kind of developed over the years that have helped me. And sometimes that helps other students that think like me. And then obviously there's students that think like Garrett and students that think like other people too. So Our approach here is really just to kind of, you're going to see a few different styles. And if you like my style or his style or somebody else's style, then, take what you think is best for you. Because especially on the in-class portion, you are going to see things from a few different perspectives. So anyway, that's all I have for right now.
Yeah, and a lot of times going through this material, I'm going to teach you guys one way to look at it, then I'm going to teach you a different way, or we're going to have multiple people in the classroom teaching you different perspectives. So take it and run with it. We do that so that you guys pick which one's your best, just like Adam said. So, so yeah. Let's see here. Hold on just 1 second. Let's see. So we figured out, after all of that said and done, this one's really easy. It's 9 degrees warmer, right? So let's take that and we're going to look at the right here. Okay. So we're going to pick an altitude. Now that we know that we have ISA and our takeoff weight. Let's see. So our takeoff weight is 60, and I just round up on these numbers. So we're going to go to an ISA plus 10 because it's a little bit warmer. Warmer always hurts our performance more. Does that make sense? The warmer it is, the bigger the performance hit. So take the most penalizing when we're doing these flight plannings. Usually, like if it's, like I said, picking the flight crap out of the pepper, then just go with whatever. But most of the time, I like to penalize more than I help, because then I give myself a little bit of a cushion. Okay. So take our takeoff weight, 69,000 pounds, and our ISA plus 9, or ISA plus 10. So we'll come out here to 69,000 pounds, which is going to be this mark here. All we need to do is follow that straight up until we run into that ISA plus 10 line. Okay, ISA plus 10. And then take that and follow it all the way over to right here. And it tells us that the highest we can go is going to be 39,000 feet. Okay. That's if we're flying the right direction. If you guys remember, we talked about NEOD Sweven. You guys remember that acronym when we were talking about navigation? So if we are flying between 0 degrees north and 179 degrees south, so anywhere, if our direction of flight is in, which it is, we use odd thousands of feet for our flight planning. Now let's say that it's between 180 or due south and going this way up to 359, we would use even 1,000 feet. Okay. So let's say that our overall flight heading was 290 degrees. Okay, we would be using even 1,000 feet. So just because we're capable of climbing up to 39,000 feet, it doesn't matter, because we're going to use an even flight level. So we would use 380. But in this case, we're headed northeast, And so we're going to use the 390. Does that make sense to everybody?
Yeah, I just haven't committed
Yeah,
it to
yes.
it yet.
Because you need separation so you don't hit each other going opposite directions, right?
Right. That's why we do the even and odd flight levels or I'm sorry, the even and odd, flight levels depending on our direction of travel. Another chart that we can use that's a little more simple than that one is down here just a little bit further. All right. So this is our other altitude capability chart. Some students like this one better. So we're flying, here's our weight, this column here, right? Our weight is between these two numbers. So we're just going to use, penalize it more. So 70,000 feet or 70,000 pounds. We know that we're using ISA plus 10. So you just, where those two meet, 39,111 feet is the absolute highest we could climb. But we always round that to a nice even 1,000 flight level.
So if your ISA deviation is, say, 11, are you going to round up to 15 or round down to 10?
If it's 11, you round up to 15.
Okay. So you're always rounding up to the next 5, essentially.
Yeah. With the performance charts. Okay. So I'm going to throw that in my route briefing guide really quick. I write down information as I go. You guys can write it down wherever. But if you guys write everything down, like when you guys get an absolute number, if you write it down somewhere, it's going to make your life a whole lot easier. Another thing that you can do that Adam taught me years ago was this Plateau tabletop type technique. So this would be our departure. You can draw this out every time on a scratch piece of paper. And then here's our destination. So KSLC. I guess I should put that there. Then you can just like right above it, flight level 390 is what we've selected. And then when we do this, we also already figured out that it's like ISA plus 9. We can take our wind speed and direction and go 310 at 9 knots. And just write down some basic information like that. I mean, that's pretty much all you need to write down is like your winds and your ISA deviation for your departure and destination. But then we would do the same thing with Salt Lake City. Just so that everything's in one spot and we can get to it quickly, right? We don't want to hunt for all this information every time we need it. We want it right there in front of us. We don't want to have to redo calculations we've already done. It's a huge waste of time. So Salt Lake City's airport elevation is 4,200 feet. Round that up to 4,500 feet. That's an ISA deviation of 6 degrees. Or, I'm sorry, not ISA deviation. ISA's 6 degrees. It's 20 degrees outside, so it's 14 degrees warmer. We'd say ISA plus 15 for our performance charts. Remember, round up to the next higher or more penalizing temperature in 5 degree increments. So ISA plus 5, write down our winds really quick. Oh, we'll use the winds off of our TAF. So our ETA was 0055 Zulu. So we'd use this first line. Winds are 330 at 10 knots. So somebody write down that information for me so I don't need to figure it all out again. Not that it takes forever, but just makes life easier. So once we've done that, Adam, do you even want us using this? Or
I think Adam left.
I think he left, yeah.
oh, he took off? Ah, man.
Just text him real quick.
He just got on to tell you guys that I do calculations different than him? How rude. Would you look at it?
He may respond to
Would you just look at it? He kept saying that. I muted my mic because I was laughing really hard.
I watched that video like a few years ago, and I still laugh just as hard, man. That's
Oh,
so funny.
Yeah.
I was on there. I just, for whatever reason, you couldn't hear me.
Oh,
Hey, Garrett, before we get too far, you said that Salt Lake was ISA plus 15.
yeah.
Can we run through that one more time just so I can double check my math?
Well, it's ISA plus 14, but I rounded up to 15 for performance chart sake.
Okay.
So our ISA, our field elevation at Salt Lake is like 42.27 or 42.28. I can't remember. We just round that up to the next higher 5,
Yeah.
so that we have a nice easy number to work with. So 4.5 times 2 gives us 9 degrees. 15 minus 9 gives us 6. So this is ISA, and it's currently 20 degrees outside in Salt Lake. So we'll just go, it's 20 degrees. It's warmer by 14 degrees. And then round up to the next 5 for our performance chart. So ISA plus 15.
Gotcha. Thanks.
Yep. All right. So let's see here.
What were you asking me, Garrett?
Yeah. I was asking you, do we really want to dive into this chart at all?
Into ISA?
No, this
Or
chart.
what?
This chart. The
Oh, yeah. You don't need to worry about that one.
okay. That's like a pilot reference sheet, right?
Yeah.
All right. So
Also, I was going to mention when you guys were talking about rounding, just remember that if ISA is negative 11, I know you brought up the example. I think Brian did or somebody did about if if it's 11, if you rounded it to 10 or 15. Well, just remember, if it's negative 11, you want to round it the other way, right? So in that case, if it was negative 11, you would round it to ISA minus 10, because and that you always want to go warmer. Just remember, you want to go warmer. A lot of people will make that mistake because they're so used to just rounding up that they round a negative up, like as in up, as in more negative. So just remember that, because that'll kind of be a little bit of a gotcha if you don't watch it when you're in the negatives. Warmer is obviously going to be less of a temperature. So
Yeah. And that's, you know, I actually do my ISA deviations like Adam does, but I'm trying to like give you guys a calculation to, some people are more practical and have to like, or literal, like in their numbers. So I try to give you guys some options there. If you do it where the outside air temperature is on top, ice is on bottom, and it's like negative 63, negative 57, which means you're adding, right? It comes out to that negative 6. That's where that calculation will come into play, and you guys can run with it that way, or you can, some people prefer like a number line. Here's negative 100, here's 0, and here's a positive 100, right? If we've got an outside air temperature of negative 63 and we know that ice is negative 57, we're moving in a positive direction. So, or I'm sorry, no, ISA, the outside air temperature is colder, so we would be moving in a negative direction. Whatever works for you guys, just get it right, okay? Just, you know. So I don't know, whatever works for you guys. All right. So here, I kind of want to just jump into doing the flight plan. Okay, yeah, that's what we're going to do. I'm not going to do any of the extra stuff that is like just filling out paperwork. Okay, that means I need to grab you guys some wins aloft, because this flight plan packet for some reason doesn't have it. So no route briefing. I don't know where to put this. Okay, there's probably some room here. this one first. Ah. All right. I'll be good enough. Jacked with the format. Sorry, I'm trying to make this a little easier to read.
Hey, Garrett, can you hear me?
Yeah.
Okay, I just was trying to make sure the phone call thing worked, so
All
I'll
right.
go back to mute.
Oh my gosh, this is a mess. I wish I would just keep the format. Okay, that's good enough, I guess. You guys get the point. Okay, so some things that I like to do really quick to make the rest of my flight planning go faster. So San Diego, we've already got all that info. Salt Lake City, we've already got all that info. We're going to do what we call the top of climb and a top of descent. So that's these two peaks on our plateau here. Oops, top of climb, top of descent. Okay, so our top of climb, we've got San Diego, then we have Las Vegas. So we know that our top of climb probably is going to fall in between those two. And our top of descent's probably going to fall somewhere between these two. So I like to get kind of an average of what our winds are going to be doing. So we'll do an overall average, and then we'll do a like top of climb, top of descent, literal winds aloft. Okay. So average, we will take at San Diego, we're climbing up. We'll probably get to, kind of a midway point. We'd probably be somewhere, we'd probably be at the top of our climb. This one belongs right there. Okay. So we'll just do an average of that 39,000 feet across the board. So we've got an average wind direction. We've got, well, it's kind of easy to see here, right? The winds are pretty consistent across the board. So our average wind direction would be 2-2. Our average wind speed is going to be, we've got 49, 47, 43, and 59. So let's take an average of those really quick. Should be about 49 degrees. So 22, 49, or 49 knots, not degrees. And then an average temp is negative 53, right? So somebody write that down really quick. Average is 224953. Now for our top of climb, we know that our top of climb is probably going to be somewhere over Vegas. Well, actually, it'll probably be before Vegas, but we're going to use Vegas's winds aloft. So 39,000 feet. Our heading wind direction is 220. Our wind speed is 47 knots, and our temperature is a negative 52 degrees. Then our top of descent will actually use Salt Lake City here. Bryce Canyon, you guys will find that your top of descent, you're pretty close to your destination. Usually within, well, always pretty much you're going to be within 100 miles of your destination. I think even less than that, probably like 70 miles. Okay, so it doesn't take you very long to descend. The pilots pull back the throttle, put the nose down, and go for it. Okay. So, top of descent, we'll just use Salt Lake City numbers because Salt Lake City is a lot closer than Bryce Canyon. 22 at 5.9 and 53 degrees Celsius. So somebody have that all written down? I should probably write it down. I should stop putting it on you guys, I guess, so that I have it.
I got it written down.
Okay, I'm gonna write it down for myself too. I need to get back in this habit here. Okay. So now we have, and we found that Las Vegas VOR is pretty much the center of our flight plan, right? If we go over to our flight plan, Las Vegas, well, Bryce Canyon's actually probably, no, Las Vegas is pretty much the center of our flight plan. So we can just use the Las Vegas numbers again for just in the center. Just do that 224752. Okay. For our winds aloft. All right, so let's figure out how this affects us. Um, let's see. Here we go. Okay, so we figure out our altitude. Now we need to figure out where's the top of climb and where is the top of descent. Because we're going to start filling out this sheet right here, our IFR flight plan. So we can actually fill a couple things out really quick on this. Point of departure, KSAN. Point of arrival, K-Slick. Flight number, you guys can put this as 1. Aircraft number, we had 730 Sierra Kilo. Captain, Phillips. I am the captain now. Dispatcher, you guys. Okay. We didn't have an alternate. Oops. Wrong. How do I? Okay, I want you to work. Okay. Let's see. All right. Alternate, we didn't have one. Selected flight level. Remember, we chose flight level 390. And then for the filed route, what you guys need to do is just take this and slap it in there. Do KSAN, remember, it's our first, and then slap that in there and do a period KSLC.
Garrett, with the flight level, are we always going to want to try and get as close to whatever maximum is allowed for us?
Yeah, we always want to climb as high as we can because it we get better performance. It's much better fuel performance. Okay.
Okay.
So yeah, always go with the highest we can go. Good question. So with this IFR flight plan, you know, me personally, I kind of like to clean it up a little bit. So I will do it like this. Because this is the way we would submit it to ATC. All right. So we know that our departure is Ksan, right? And we're going from Ksan to our top of climb for our first, we call them legs, okay? So we'll break up this route into a couple legs. It may be as short as top of our departure to top of climb, and from our top of climb to top of descent, and then our top of descent to our destination. But we may have several legs. We may have our destination, our departure to our top of climb, and then we may have 3 or 4 legs going from VOR to VOR, and then our top of descent. So it just depends on how much distance we're covering overall. But there's a couple things we do know that we can throw in here really fast, right? We know when we use the route box here, we know that we're doing the border 7, right? So we can do BR DR 7 because that's our SID. This is telling us what flight level we're going to. Our true airspeed, we're going to figure that out. We're going to figure out all of this information. Okay. KSLC, in here, we can throw in that our star is Jammin 5. And, you can put an arrow going down, whatever you guys want to do there. But we're descending from our cruise. Okay. Yeah. So we've filled out the first part of our IFR flight plan. Now let's go get some actual numbers. So when we're looking at this, we need to take our information that we got for San Diego. I need to close down the stuff I don't need. Okay, so we got ISA plus 10, right? Is what we're going to be using for our chart. Does everybody agree?
Yes.
Okay. And Salt Lake City, we got ISA plus 15. Okay. So now we take that number and then we take our weight at our departure. Okay. So our weight at departure is 68,592. Our weight at landing, you guys can write under KSLC, is 63,292. Okay, this is just going off of our estimated fuel, right? So let's figure some things out. Let's go over to our performance charts. And when we're getting to this point where we're trying to get our actual performance numbers, this is how you read the chart. So the climb, this is a climb chart. It says climb on it. We know it's a climb chart. It also says climb data here, right? This is to decide where is our top of climb, okay? How much fuel are we going to burn? How long is it going to take to get to the top of climb? That's the information we're going to pull off of this chart. You'll notice that each one of these charts has the ISA deviation on the top. So what you guys need to do is find which chart has our ISA deviation that we've planned. Right. So at San Diego, we planned on ISA plus 10, and then we need to go to our takeoff weight. So it's going to be ISA plus 10 climb chart, and our takeoff weight, we're just going to round up to 69,000 feet, right? So it's in between those two. We also know that we're climbing to flight level 390. So here's where we're going to get our numbers, is between these two boxes. Everybody see that?
Yes.
Yeah.
All right, up here is the key for deciphering the information in this box. So the three things that I told you we need, we need four things, okay, are going to be how long does it take, the distance that we're going to travel, how much fuel we're going to burn, and how fast are we going to climb. Okay. So the first number, time in minutes, we've got 25.8 and 27.5. Since it's between the two boxes, we're just going to take an average. Okay. So 25.8, 27.5 divided by 2, 26.65. We're going to say 26.7 minutes. We're just going to round it to the nearest tenth. Does that make sense? Everybody following? So we figured out this number here, our time. Okay. Now we'll go to our distance. We've got 166 and 177.8. So 166, 177.8. You can take that, divide it by 2, 170.
179.
Yeah. So 171.9. So this is our distance. Okay, now let's look at our fuel. On this chart and our descent chart, it is taking into account both engines, okay? So this is how much total fuel using both engines are we going to use. So fuel, we've got 2447, 2619. Oops, 2477 plus 2619 divided by 2, 2548. And then the last one is our speed. Okay, 387, 386. Let's just say that it's 387. Cool. So now we just plug it in here. So this is for our top of climb. There's 2 spots that we plug this in. We can plug it in these 4 boxes down here. So this first one is time, 26.7. Fuel, 25.48. And down here, distance was 171.9. And our knots true airspeed was 387. So now we can erase all that. And we're going to do the same thing up here. So this is our knots true airspeed. Okay. Our magnetic course, we need to come in here and figure that out really quick in Sky Vector. So I'm going to teach you guys something really cool. Make a mental note of what I do here. I come up here and I can go to this button here. Does everybody see where my pointer is? And I can click that. Okay. So to figure out our average heading for during our climb portion, if you guys remember that our distance was 171.9 miles. Okay. So we're going to go out 179 miles approximately and then take an average. So 54 plus 71 is 125, right? 125 plus 68, we're going to be a little past that, right? So I can just take these headings and do an average. Okay. 95 plus 21 plus 28, divide that by 3. That gives me an average heading of 0.48. Hey, I still remember how to do it. Okay. So there's our average heading. When we are doing this portion, so our climb and our descent, if you guys remember me saying this, we don't account for winds. There's no magnetic variance, there's no winds, there's nothing, okay? We're not crabbing into the wind or nothing. We don't account for it at all, okay? Because the wind's going to change so much during the climb, it's not even worth trying to calculate. The computer does it all itself. So you can put your ISA deviation in this box. ISA plus 10. Okay. Like I said, since we're not correcting for the wind, we can just put in our magnetic course, magnetic heading. We're just going to keep the same. Our ground speed is also going to stay the same. Okay. So now we've figured out our top of climb. The other information that we can throw in here is just this information down here. So distance 171.9. The time it's going to take, 26.7. The amount of fuel we're going to burn, 25.48. And then the aircraft weight when we took off was 68,592 pounds. Okay. Now, since this is our first leg, we can just copy these numbers down. See how there's an equal sign at the beginning of that box? We'll tally them up as we go. But here at the aircraft weight, we're going to subtract that 2548 because we're burning that fuel. Does that make sense? So,
Yes.
so let's do the math really quick. 68,592 minus 2548. Somebody have that? All right, I'll do it. So our weight at the beginning of our next leg is 66,044 pounds. Okay. All right, now we do the same thing for our top of descent. Okay. All you're going to do is you're going to take your landing weight of 63,292 pounds that we figured out on our weight and balance chart right here. Okay. And 99% of the time, our fuel burn at that point is going to be like 500 pounds. So let's come down here to our ISA or our descent chart. You can see these charts here. The next ones in line are going to be the cruise portion, right? So we're just going to keep going until we find our descent. So here we find our descent chart, but this is the ISA minus 10. And we need to go to the ISA plus 15, right? ISA plus 10. Oh, the next warmer chart is ISA plus 20. We don't have an ISA plus 15 chart. So all right. Remember, we're penalizing in our temperature. So ISA descent, you can see here that our average fuel burn on most of this chart is going to be like 200 to 400 pounds. Sorry. So that being said, if we just add like 400 pounds onto our landing weight that we are guessing we're going to be at, so that makes it our top of descent 63,700 pounds. Then yeah, so 67,000 or 63,700 pounds. So let's go up to that weight. We're looking at the ISA plus 20 descent chart, and we are descending from flight level 390, and we weigh 64,000 pounds basically. So we're going to use this box here. So let's write down these numbers really quick. 17.3. For our time, we need our distance, our fuel, and our airspeed again. So distance, time, fuel, 113.4, and 394 knots. Okay. Now we just take it, jump over to our flight plan box. Just like the other one, we're going to slap it in here. 17.3 minutes. 376 pounds of fuel. Distance 113.4, and true airspeed 394. Okay. All we do is throw that in here. Now, and Okay. Let's add that in here. And then we will talk about next week and just cut this flight plan a little short. So our true airspeed 394. Our direction, we now know that our distance is 113 miles. So the Jammin 5 is 153 miles. So our heading is going to average that 7 degrees. So we can go 007 degrees. Once again, we're not accounting for wind. ISA, we used the plus 20 chart. And just keep our 007 Bond, James Bond. And then 394. And we are just going to throw this in here. We're not going to tally things up, though. Okay, not until the very end. So our distance was 113.4. Our total time that it was going to take us is 17.3 minutes. Our total burn is 376 pounds. And we don't know what that weight is going to be. All we know is how much we're going to burn. So we can take that and put it in here. Okay. And there we go. You guys have now seen how to start your flight planning. All we're going to do on Monday is connect the two dots. We now know that our distance between the 2 points, our takeoff or our top of climb, top of descent, we know those distances, 113.9, right? And 100 and what was it, 71.9 or something. Anyways, we'll just connect those two dots on Monday. But it's the same exact thing that we just did, except for now that we're in our cruise, we can account for winds because winds are going to be a lot more steady at altitude than when we're climbing or descending. So we'll do a wind correction calculation, and that's pretty much it. So pretty simple, right? You guys feel like you could do this, or
No.
well, you will, damn it.
I know.
But yeah. Okay, so let's talk class next week for the last 15 minutes. Um, All right, the class. We are going to be meeting, let me pull up the address here. At the Hyatt Place in St. George. Okay, 1819 South, 120 East. And for you people that are locals, if you just get off on Dixie Drive or on Bluff Street and come down here, there's the Culvers on the corner there. Just there's the brand new Holiday Inn. It's right next door to the brand new Holiday Inn. Or is it Hilton? No, it's a Holiday Inn. Yeah, it's the Holiday Inn. So, brand new Holiday Inn. Right next to each other. Share the same parking lot. Okay? Let's see. There's your address, location. So this is for the first week. We have this conference room for the first week only. The next week, the second week of in class is going to be next door at the Holiday Inn. Okay? And when you get there, you can just ask them where their conference room is. Or if you can remember the Hyatt, the conference room is, if you just go to the elevator, past the reception desk, go to the elevator, go up to the second floor. As soon as you come out of the elevator, that's the conference room right there that we're going to be in. Okay. Let's see. What I need you guys to bring to class is going to be, I need you guys to bring a laptop or some form of electronic device bigger than your phone. So an iPad with a keyboard or whatever you guys have, please bring it. I'll be there with my 27-inch Mac. Thing weighs a ton, but it makes my life easier to have that in front of me than my iPad. So bring your laptop, bring an E6B. Okay, I don't want you guys to...
Can we use a manual one, or does it have to be electronic?
Does your manual one, and that's what I was about to say. The manual one, if your manual one goes up to 600 knots, and you are super confident in your abilities to use it, go ahead.
What is an E6B and where do I get one?
This is where you get one. The App Store. So do you have Android?
I just download it?
Yeah, do you have
No, I'm Apple.
Okay, good. Let me show you.
Can't we bring that into the ADX test too?
Yeah.
But I can't bring my phone, right?
Right. But you don't
So
need
how to,
an E6B on the ADX.
okay.
I would be shocked. I don't remember any questions that required it. So if I'm wrong, I'm really sorry. But I know without a shadow of a doubt, I never used it, and I don't think any one of my students have ever used it.
Well, and with I actually was talking to Shepard about that and where you would need one. They haven't changed the questions in years. So they've got them already there. So just memorize the answers.
Okay, does everybody see my phone here?
Kind of circulating.
Can you just type the name of the
I can.
producer?
I can, but that would be too easy.
Oh, Garrett, come on.
I know. So there you go. Flight ready E6B.
And does that need to be on our computer, or is that can just be on our phone?
Just you can. I prefer it on your phone. It'll be easier and faster. So do you guys see it? It's got that little paper airplane. It's 99 cents. If you guys need me to loan you $1 to buy it, I will do that. In fact, it won't even be a loan. I'll pay for it. Okay, that's the Apple E6B.
Purchased.
Okay.
What are these any good for Android? Air conditioners for Android?
I don't have anything PC or Android. So there's one on there that I know is free. Let me see if I can find it. No, I'm not going to install that. There's a free one, and I can't remember the name of it.
Looks like there's 5 or 6 free ones.
Yeah. So just grab one of those. What it needs to have on it. Let me show you guys. The screen. So I have like an old school calculator one too. That I can pass around the class. It's like an actual calculator. It's not a manual one. But it's specifically made for. All right. So going back to my blurry screen because I'm a jerk. This, and you can see all my construction behind me. This is what you guys need to have is heading and ground speed, and it has like wind direction, true course, true airspeed, true heading, all that on there. Okay, That's what you guys need. So as long as it has that, download any free E6B you want. Okay. I will print out a bunch of those manuals that if you guys want one, I'll just have them there. Let's see. Brings like a notepad, scratch paper, bring pens and pencils, bring your little caboodle box or whatever they used to call them in the 1990s. What were those things called? You know, your pencil box, whatever. I don't know. Sorry, I'm trying to be an idiot. And it's late.
Is that the plastic one where there's like bumps on it and stuff?
Oh
It's
yeah.
like a clear plastic.
Oh yeah.
I know what you're talking about. I don't know what it's called though. I used to have one.
And then bring your like pocket protectors and stuff like that because we're gonna geek out.
Trapper Keeper.
Yeah,
Lisa
Trapper
Frank,
Keeper.
Trapper Keeper.
And then those cool little folders that have the geometric designs on the cover. You know what I'm talking about?
Yeah.
Everybody had one. Anyways, bring all that stuff. You know, just normal school supplies. Your laptop, that E6B, and let me see. I'm trying to think of anything else. And a good positive attitude. And that's pretty much it. What questions do you guys have for me?
So we're just gonna meet at this hotel at like 5:30.
Yeah.
Okay.
I was planning on going earlier. Are you down with that? Do you want me to text you or?
Yeah, so I just asked Adam, and I need to get the clear from the hotel. He reserved it for 5:30 to 9:30, I think. So last time the Holiday Inn was chill and just like let us have the hotel, that conference room all day, every day. I don't know so much about the Hyatt place. They're like, a little more expensive of a hotel. So I need to confirm with them how early we can be, how late we can stay. But like I'll probably be there at like 4:30 or 5 at the latest. Just because I got a lot of crap that I got to set up. So if you want to come then please do. If we want to meet earlier than that, shoot me a text, let me know.
Okay.
And we can probably meet at either the Dixie State Library or the Washington County Library.
Well, another thing is too is that a place like almost all these hotels like have a breakfast area that isn't used during the day, and they'll almost always, especially if you've got something going on later, you can just pretty much hang out in the eating area, and sometimes they're cleaning and whatnot. But I had a job that I had to do that a lot in a lot of different hotels, and they're almost always really cool with that. The only problem is they got the lobby music playing.
Yeah.
But other than that, they'll let you just hang out because it's not use space. You're paying for space later in the day. So it's like a 99.8% certainty that would be a useful place to hang out.
At Dixie State, they let you reserve conference rooms too. You just have to like schedule it.
Okay, well, thank you. I'm out for the night.
Yeah, I think I'll follow suit.